Hello students, how are studies going? Hope you are doing good. We are back with another video, and in this video we are going to teach about stoichiometry. This is a basic chapter from chemistry. So without wasting any time, let us start the video. Hello everyone, my name is B.Aditya. Welcome to my channel. Subscribe for more MPC content. So let us begin our video. So before starting significant figures, I want to give you something. I will put it on the screen. I will put 3 photos, so you can take a screenshot or make a note of it. Those are very important conversions which you need to have a note of. So they are most of them are not useful in this chapter, but in physical chemistry they will be very useful. So E/M ratio of electron, mass of proton, mass of electron, conversions of 1 Armstrong, 1 AMU, all that I am giving on the screen. So please take a screenshot. Okay, now let us start our video. So in this video we are going to discuss about significant figures and laws of chemical combination. In the next video we will start mole concept. Okay, so significant figures, it determines certainty of a number. It is like rounding of numbers. There are some rules for significant figures. The first rule is all non-zero digits are significant. Okay, all the non-zero digits are significant. Example 43.8 has 3 significant figures. Okay, all are non-zero digits, so there are all the digits become significant figures. Next one, a 0 becomes significant figure when it is between 2 non-zero digits. Okay, so here 5.036, 0 is between 2 non-zero digits, therefore it becomes significant, and this has 4 significant figures. I have underlined the significant figures here, so you may make a note of it. Okay, so the next one, zeros placed to the left of non-zero digits are not significant. Now these are non-zero digits, the zeros are placed on the left to them, so they don't become significant. Only the non-zero digits are significant. Okay, so these 3 are significant. Zeros placed to the right of decimal point are significant. Okay, so 27.00, zeros are placed after decimal point, therefore each and every one of them becomes significant. Okay, the next one, if a number ends with zeros but they are not to the right of decimal point, they may or may not be significant. Okay, so for example we have 270, so here it ends with 0 but this is not after decimal point, so we can write this as 2.7 into 10 square, 0.27 into 10 cube, and 27 into 10. So this may or may not be significant. Okay, so the next one, counting objects like 2 eggs, 20 pencils, like any value which is a whole number, it is not a decimal value, has infinite significant figures, as they can be written as 20.0000, 2.0000. So after decimal point you can place many number of zeros, infinite number of zeros you can place, so they have infinite significant figures, as zeros placed to the right of decimal point are significant. Okay, I hope you have understood. And the values like pi, which is never ending values, have infinite significant figures because you cannot determine them. Okay, and most of them are non-zero digits, so please make a note of this or copy this. Then we will move on to laws of chemical combination. Okay, I hope you have made a note of it. So in this video we will discuss only the concept part. In the coming videos we will discuss sums in all kinds of topics. So the next video will be on physics, which is going to release day after tomorrow. In that video we will bring many good numericals from all the topics, covering all the topics like elastic collision, non-elastic collision, partially non-elastic collision. So everything numericals we will cover in the next video, which is going to release day after tomorrow. So now let us begin laws of chemical combination. Okay, laws of chemical combination. Okay, each law I will write on the board and I will give you an example. So what are laws of chemical combination? So when two elements react chemically, like H2O is forming by the reaction of hydrogen and oxygen. So there the reaction follows some laws. Okay, so those laws are known as laws of chemical combination. Each and every compound which reacts chemically needs to follow these laws. So the first law is law of conservation of mass. Okay, this was proposed by Lavoisier. Okay, so what does this law state? This law states that mass can neither be created nor destroyed. Okay, when two elements react, the initial weight should be equal to final weight of compound, that is weight of reactants should be equal to weight of products. Like if let's say C plus O gives rise to CO, carbon monoxide. Okay, so I am not writing the balanced equation here for everything. You need to balance it later. We are just telling the examples. So here let the weight be X, Y, then the total weight formed should be X plus Y. Okay, here new mass is neither created and mass is not destroyed. Okay, in some compounds the like hydrogen will liberate out of the reaction or CO2 will liberate out of the reaction, but after the reaction the liberated CO2 mass also we should count. Okay, the total mass of initial reactants is equal to total mass of products. Okay, you can copy this. This was proposed by Lavoisier. Okay, you may make a note of it, then we will move on to the next law. The second law is law of multiple proportions. This was proposed by Proust. Okay, so what does this law state? This law this law was proposed by Dalton. So what does this law state? So when a fixed mass of an element reacts with different masses of other element, the ratio of masses of the other element will be in a simple whole number ratio. Okay, for example nitrogen. So nitrogen reacts with different amount of oxygen, like it reacts with 16 grams, 28 grams nitrogen reacts with 16 grams, 32 grams, 48 grams, 64 grams and 80 grams of oxygen. Okay, so the fixed mass of one element reacts with different masses of other element, then the ratio of masses of other element will be in a simple whole number ratio. So 16 is to 32 is to 48 is to 64 is to 80 is 1 is to 2 is to 3 is to 4 is to 5. Okay, so when there is fixed mass of an element, that is nitrogen, which reacts with different masses of oxygen. Okay, we shall say weights, not masses, different weights of oxygen. This will be in a simple whole number ratio, 1 is to 2 is to 3 is to 4 is to 5. Okay, so let us move on to the next law. Hope you have copied this. Okay, so the next law is Law of definite proportions. Law of definite proportions. This is also known as law of constant proportions. Definite proportions. So this was proposed by Proust. Okay. So what does this law state? This law states that when two or more elements react, they always follow a simple, their weights, their weights always follow a simple ratio, whole number ratio, irrespective of method used to prepare. For example, okay, so let me explain it again. When two or more elements react, chemically they react, their weights always follow a simple ratio irrespective of the method used to prepare. So, for example, if we take carbon dioxide, CO2, so carbon dioxide is also formed by heating CaCO3. So CaCO3 is nothing but limestone. Okay. So delta is heating. When we heat limestone, CO2 gets liberated. Okay. And when we react carbon and oxygen, CO2 is formed. Okay, I am not writing a balanced reaction here. So carbon and oxygen, when they react, it also forms CO2. So here CO2 always follows a simple whole number ratio. That is, the masses of weights of carbon and oxygen always follow simple whole number ratio 12:32, because the mass of one oxygen atom is 16 grams, two oxygen atoms has 32 grams, the mass of one atom of carbon is 12 grams. So the ratio is 3:8. Irrespective of the method prepared, the final carbon dioxide will always have the weight ratio 3:8. Okay. So I hope you have understood this law. So please copy this one. Then we will move on to the next law. So the third law is law of reciprocal proportions. Okay. This law was proposed by Richard. Okay. So what does this law state? This law states that when a fixed element or a fixed mass of element, fixed mass of the same element reacts with two other elements, then the masses of the two other elements when reacted be in a simple whole number ratio. Okay. Now let us take an example for this one. When a fixed element reacts with two other elements, then the masses of the two other elements when reacted with each other is in a simple simple whole number ratio. Okay. So for example, if we take hydrogen, oxygen and sulfur. So hydrogen reacts with oxygen and forms H2O. Hydrogen reacts with sulfur and forms H2S. So the same mass of same element. Okay. So when these two react and form SO2, their masses will be in a simple ratio. For example, H2O, hydrogen 2 parts, oxygen 1 part. H2S, hydrogen 2 parts, sulfur 1 part, SO2, sulfur 1 part, oxygen 2 parts. So the ratio will be 32:32 equal to 1:1. So they may be equal or they may be in a simple whole number ratio. Okay. So I will explain this once again. Hydrogen reacts with oxygen and forms H2O water. Hydrogen reacts with sulfur and forms H2S. Okay. So when sulfur and oxygen react, they form SO2, and the masses of sulfur and oxygen in the reaction will be either equal or in a simple whole number ratio. So this is a very important law. You may copy this one. Then we will move on to the next law. Sorry, this is 4. Please copy this one or take a screenshot. Then we will move on to our next law. Okay. The fifth law is Gay-Lussac's law of combining volumes. So this was proposed by Gay-Lussac. It is given in the item itself. So what does this law state? This law states that when gases react in similar conditions, same temperature and pressure, their volumes are same. And if the product is also a gas, the simple whole number ratio, also applies for product. For example, hydrogen plus oxygen gives rise to H2O. Okay, this is a balanced reaction, but we are ignoring all this right now because you can balance it in the exam. I am not balancing it right now. So 2 liters of hydrogen, 1 liter of oxygen gives 2 liters water vapor. Okay. Let us assume this is gas for now. This is gas in gaseous form and gaseous form. 2 liters of hydrogen when reacted with 1 liter of oxygen gives rise to 2 liters of water vapor. Okay. So this was about Gay-Lussac's law of combining volumes. So please copy this one. Then we will move on to our last law. Heading itself, the law was proposed by Avogadro, Mr. Avogadro. So, what does this law state? This law states that when gases react in similar conditions like temperature and pressure, the volume is proportional to number of moles. Volume of gases is proportional to number of moles. That is V1 by V2 is equal to N1 by N2. Okay, that is number of moles. Sorry. Molecular weight is equal to number of moles into N. Okay. So this is about Avogadro's law. So that is it for the day, guys. Hope you have understood the lecture. In the next video, we will bring mole concept. And sorry for the voice quality. There was a mic issue this time. From the next time, it will not repeat. Thanks for watching.